In this video, we are going to see how to solve one of the best known algorithmic puzzles, the Tower of Hanoi. For those of you who are not familiar with this puzzle, it essentially consists of 3 rods with a variable number of disks of different sizes, as shown on the screen. The objective of the puzzle is to move the entire stack of disks on the last rod. However, it's not that simple. You must follow a few rules. Only one disk may be moved at a time. Each move consists of taking the upper disk from one of the stacks and placing it on top of another stack or on an empty rod. No disk may be placed on top of a disk that is smaller than it. The problem can be approached in 2 different ways, using recursion or using an iterative approach. It illustrates perfectly the benefit of using recursion instead of iteration, therefore we are going to solve it using recursion. Tower of Hanoi is not that often used as a challenge in tech interviews. However, it enables you to get accustomed with recursion, which is really helpful in solving other coding challenges. We're going to use Java for this demonstration. What the algorithm will do is that through recursion, it will move plate by plate until the whole stack is moved on the rod from the right. Without further ado, let's start our IDE and see the solution to this puzzle. As you can see, we have an empty class here called the Tower of Hanoi. I'm going to create a new function that will host the algorithm for solving the problem. In terms of parameters of this function, we need to get the number of disks that we have in our problem. We don't have to store the size of the disks in a separate variable. We will just assume that the disk number 1 is the smallest, whereas disk n is the biggest. Next, we need somehow to objectify the rods. That is, giving them some names so we can reference them. Tower of Hanoi has a variable number of disks, but always the same number of rods, which is 3. I propose to have a character that will refer to each and every rod, so I will add 3 more characters parameters as follows: first rod, third rod, and second rod. As this is a bit counterintuitive, I will explain why I chose the third rod in the middle. Our objective is to bring everything to the third rod. The second rod is more of an auxiliary one, with the aim to help us achieve our goal. Therefore, the importance of it is less than that of the third rod. So that's why I chose to have this order instead of the natural order of having first, second, and third rod defined. Alright, now that we define the signature of this function, let's start writing the algorithm. Since we use recursion, we need to set up an exit condition. Otherwise, we risk running the function indefinitely. Therefore, I'm going to specify here an if condition. If the number of rods is equal to 1, then I'm going to print the message that we just moved the disk from first to third rod and we return. If the number of rods is different than 1, we're going to invoke the same function recursively, and we will send as parameters the number of disks minus 1. Since we subtract a disk from the stack, first, second, and third rod. The reason why we send the first and second rod as parameters is because we will make use of the second rod first. Next, we print in the console that we move the disk n from first to the third rod. Then we call the function again, and we will supply n-1 again, second rod, third rod, and first rod as parameters. And we close the function. The code is a bit confusing at this point. Why would we need to call the same function twice? Let me show you what the code is doing in debug mode. First, let's define the entry point of the program, which is the main method. Here we will define 3 disks and call the function. Let's put a breakpoint at the beginning of the method so we can debug it and start the program in debug mode. First, the program checks if the number of rods is equal to 1. which is false at this point, and it goes further. The number mentioned alongside the character is the number corresponding to each character, so we ignore it for the moment. It then calls the method recursively, with the parameters listed on the screen. As the function has been called again, it jumps back to the if condition. This is also false, so it calls the method again recursively. We now have n equals 1, so print this message into the console and return. We now moved disk number 1 to the third rod. Since we returned, we move to the next system output, and we print that we move the intermediary disk from first to second rod. Why is that? Because only the last method call has returned, and we are now in the second call, which has the rod B assigned as the third rod. Next we go into another call, where we supply the same order of rods as before. N is equal to 1, so we print that we move disk number 1, which is the smallest, from rod C to rod B. We return, but we are still in the first recursive call, so we print again something that the disk number 3 is moved from A to C. We then call the method recursively again. And this time is not equal to 1, so we call the method again. At this second call, n is equal to 1, therefore we move disk number 1 from B to A. Now let's pause for a second. Our tower looks like this right now. We just need to perform 2 more operations, moving disk 2 to C and then disk 1 to the same rod. First operation is performed next in our algorithm. As we can see here, and as we go to the next step, the Tower of Hanoi method is called again, n is equal to 1, and we do the last operation and exit the final function call. We now have reached our objective, meaning that we moved all the disks to the right rod. I encourage you to download the code attached to the description and try to play with it yourself. You can increase the number of disks and try to run it in debug mode, so you can see the exact order of actions. I hope this was helpful for you to understand how to tackle the Tower of Hanoi problem. Thanks for watching this video.